In part 2 of the lecture on describing motion, I will discuss displacement and distance and what is the difference between the two physical quantities. As discussed in the previous part, in part 1, displacement is a vector quantity and distance is a scalar quantity. So that means that distance is described simply with its magnitude, while displacement will be described with a magnitude and the direction, or a direction that can be assigned to it. First, let's talk about displacement. Displacement, as I already said, is a vector quantity with magnitude that is equal to the straight line distance between two positions in space. The direction of the displacement as a vector quantity is given by the choice of which is the starting position and which is the ending position of the motion. Displacement is a vector quantity with magnitude that is equal to the straight line distance, and this is very important, the straight line distance between two points in space. The direction is given by the choice of starting and ending positions. So let's decipher what this definition means. Okay, so consider 2 points in space. Let's say we have town A and we have town B. So town A will be the starting position of motion, I will also refer to the starting position as the initial position. And then we have town B as the ending position or final position. So most often in this course, I'm going to refer to the two positions, starting and ending, as initial and final position during the motion of an object. And so now let's imagine that a car is traveling between the two towns, and the path between the two towns is not a straight line. It's a random shaped path, let's say something like this. So the car starts from town A, that's the initial position, and travels along this path to town B, which is the final position. Okay, so then what is the displacement of this car according to the definition that I stated right here? That is the straight line distance between the starting and ending positions, between the initial and final positions. So then the displacement is not this path that the car took, it is this straight line. That is the displacement. Now I also must indicate direction, because displacement is a vector quantity, so therefore there is direction. The direction was defined by the choice of initial and final positions. So the displacement is from the initial position towards the final position. And the easiest way to indicate direction would be to use an arrow. So I can use an arrow like so to indicate that the displacement was from town A to town B. And so this is the displacement here. The straight line distance between the two. Imagine that these two towns are somewhere in the mountains and there is no a straight line path between the two. The only possible path to take is this path. That still doesn't change the definition of displacement between the two towns. It is just the straight line distance between the two towns. So this is very important. No matter what the shape of the path between the initial and final position is, the displacement between the initial and final position is always the straight line distance. Okay. Now let's talk about distance. Distance is a scalar quantity. There is no direction associated with distance. It is simply the length of path that an object will travel between 2 points. One more time. Distance is a scalar quantity which is equal to the length of path between 2 points in space. So let's look again at our two towns, town A and town B. And town A is our starting point or starting position or initial position. And town B is the final position. And so let's assume that there are several different paths which a car can take to get between the two towns, from town A to town B. For example, the car could be traveling on a path that looks like so. So this is path number 1, or along a path that looks like something like this. So this is path number 2. So in either situation, the distance traveled will be simply the length of the path that the car took. However, for both situations, for both instances, the displacement is the same. And that, from our previous definition, is the straight line distance between the initial and final positions. That is the displacement. So as you can see, the distance between the initial and final positions can be anything, depending on just the path that the moving object takes between the two positions. However, the displacement will always be the same. The straight line distance between the initial and final positions in space. I want to pose this question to you guys. Can distance and displacement have the same magnitude? When can that happen? Under what conditions? The units for displacement and distance are the units of length, meter, or kilometer, depending on the distance that's being measured. The base unit, of course, is meter, and for our calculations, typically we are going to have to convert any distances from whatever unit they are given to meters in order to get the results correct. Let's do 2 examples to illustrate how to work with displacement and distance. A runner starts his run from his house due east for 2 kilometers. Then he runs north for 1 kilometer, west for 2 kilometers, and finally south for 1 kilometer. The first question is, what was the distance traveled? And the second question, what was the displacement? So for those types of problems, it is very beneficial to introduce a reference frame, such as a map with directions east, west, north, south, in which we can sketch the movement of the runner. So here is the map. So this is north, this is south, east, and west. It's always easiest to consider the motion starting from the origin of the map. So right here, the center of the map. Now let's sketch the movement of the runner and let's see what it looks like. So the runner initially runs due east for 2 kilometers. So the runner goes in east direction for 2 kilometers. Then he runs north for 1 kilometer. North for 1 kilometer. then west for 2 kilometers, and finally south for 1 kilometer. So this is the sketch of the movement of the runner. So one more time: east 2 kilometers, north 1 kilometer, west 2 kilometers, and then south 1 kilometer. So I included arrows here to indicate the direction of motion. So the first question was, what was the distance traveled? The distance traveled is simply adding the distances in each direction. So we have 2 kilometers plus 1 kilometer plus 2 kilometers plus 1 kilometer. And so the distance traveled is a total of 6 kilometers. So this is the length of path that the runner ran from his starting position to his ending position. The second question is what was the displacement of the runner? So the displacement in general is defined as the straight line distance between the initial and final positions of the motion. So what is the initial position of the motion? This is the start of the run, which is at the origin of this map. What is the final position of the run? It also is at the origin of the map. So the runner started from the origin, ran around this path, and then came back to the origin. So the initial and final points of the motion coincide. They're on top of each other. Therefore, there is no straight line distance between the two. Therefore, the displacement is simply 0. So the displacement is 0 kilometers. This example shows you the very important difference between distance and displacement. Distance is only 0 when an object is actually not moving. It's at rest. But once there is motion, the distance traveled is never a 0. However, the displacement can be 0 if the initial and final positions are the same. Here's another example. A dog goes for a walk. It leaves its dog house and walks 180 meters due east. After that, the dog turns around and walks 50 meters due west. What are the dog's displacement and the distance traveled? So this problem is very similar to the previous problem. So let's use the same concept, introducing a map, sketching the motion of the dog on that map, and use those to calculate the distance and the displacement of the dog. So the dog started from his dog house right here, moved 180 meters due east. So this distance here is 180 meters due east, and then turned around and moved 50 meters due west. So 50 meters due west. So the dog ended up somewhere here. So this is the final position of the motion of the dog. Let's calculate the distance traveled. The distance traveled is simply the distance from the starting position to where the dog stopped, plus the distance from the dog turning around to its final position. So that will be 180 meters plus 50 meters. So that is 230 meters distance traveled. The displacement, however, is different. That will be the difference or the straight line distance between the initial and final positions. So this is the initial position of the motion. That's the dog house. The final position is right here, 50 meters from where the dog turned around. And so the straight line distance is the distance from here to here. How much is that? Well, this is 180 meters minus 50 meters. Or that is equal to 130 meters. So the distance traveled by the dog was 230 meters, but the displacement only 130 meters. In the next part of the lecture, I'm going to discuss velocity and acceleration.